Yeah, welcome audience. I'll be giving a 10 hours lecture course on these mathematical methods for boundary value problem. And I myself is Professor Somnath Bhattacharya, Mathematics Department of IIT Kharagpur. So, basic overview, as an overview, I can jot down few lines like this way. So, basic idea is to provide a course where all these situation, all the things can have a introductory things. Like I started with a linear boundary value problem where the analytical techniques based on eigenfunction expansion or Green's function theory. So, that can be illustrated, and then we have switched over to nonlinear boundary value problem, which cannot be handled by those analytical techniques, and those are done by numerical methods. So, the boundary value problem will be emphasized. So, numerical methods in the beginning we have given little bit introduction for initial value problems like Runge-Kutta methods and others, and then converting the boundary value problem to a shooting method, that is a equivalent initial value problems, and then finite difference methods for linear and iterative methods for nonlinear, as well as for partial differential equations for linear situations like heat transport equation, Crank-Nicolson method, then successive over relaxation methods for solving Laplace or Poisson type of equations, then ADI scheme when you have a dimension for a transport equation where dimension is higher than 1. So, this kind of situations has been will be illustrated over here. And also the numerical instability, some complicated terms like truncation error, instability, order of accuracy, so how good the method to compare to others, that also will be elaborated in a short form in this. So, basic idea is that we have a general overview for all this linear as well as linear homogeneous or non-homogeneous boundary value problem or non-linear. So, that will be done by the numerical technique. Now, for this course, objectives is the following. Focus of this course is to introduce some powerful technique, both analytical and numerical, to solve BVPs. That is what is the abbreviation for boundary value problem. Now, in there are several courses exist in even in NPTEL websites and others, as well as books, which either talk about the linear situation analytic methods, that is integral transform techniques, Fourier series expansion, eigenvalue expansion, or in Green's function theory, separation of variables and all. So, we will discuss a portion of this course is will be introduced those portion, those ideas or those techniques, and then we will have the other portion is on nonlinear boundary value problems to handle that nonlinear boundary value problems by finite difference methods and shooting methods and iterative methods when it comes to a nonlinear situation. Now, the course is designed in such a way that one need not have to depend on the previous, some prerequisite is nothing is there, only you have to have a familiarity with basic mathematics, differential equations, this kind of things is only the prerequisite. It is not that you have to be well equipped with several other techniques or courses and all these things. So, the course can be a very good course for the UG level as well as a first course for the PG level like PhD course, those who are going to do the mathematical modeling, or for the MTech guys, those who will have the mathematical modeling part. So, this gives a basic introductory idea about how to proceed further. So, and the intended audience I can say like this way, the undergraduate of any engineering course, mathematics, physics, postgraduate students of mathematics, mechanical, aerospace, chemical engineering, and as a first course for MTech PhD level involving mathematical modeling. Also, it can serve as a preparation for GATE or NET or JAM, this kind of competitive exam, at least the first stop where we have talked about the linear situation, eigenfunctions and the Sturm-Liouville problems, those boundary value problems and Green's function theory. So, these are all very common in GATE or NET exams. And also the finite difference method, say based on these Craig-Nicholson methods and all. So, it serves also for the competitive exam also, and it can be a course, a full course for UG level in all these mathematics related topics, and also it can be a first course for the PhD or PG level. Now, about myself, I am a, as you could see from my appearance, that I am quite a senior guy, senior professor of mathematics, and I did PhD from IISc Bangalore in CFD, and I am here in IIT Kharagpur for the last 26 years. I am teaching in applied mathematics related topics, and my research is basically mostly on fluid dynamics, microfluidics, nanotechnology, and etc. So, all the mathematical modeling basically. So, I have some 120 publications and all, guided 15 PhD students, and also I have given several AICTE sponsored course, NPTEL course and GIAN course, and several conferences I have organized and all these things. I was also visiting fellow in abroad and postdocs and all these things. So, as a course outline, I gave this way, that the very first two lectures, which will be the, as I said, based on emphasize on this linear BVP and Sturm-Liouville problems, eigenvalues, eigenfunctions, which will be introduced there, and then the solution of BVPs, homogeneous or non-homogeneous, by the eigenfunction expansion technique, then solution of linear parabolic, hyperabolic and elliptic type of PDEs with finite domain by these eigenfunction expansions. Then we will talk about the Green's function for non-homogeneous linear boundary value problem, for ordinary involving ordinary differential equations or the elliptic type of equations, harmonic functions, maximum principles, all these things will be introduced. Then we will talk about the numerical techniques for initial value problems, an overview, and then we talk about the stability and shooting method to convert the boundary value problem to a equivalent initial value problem and solving that boundary value problem. Then we come to the finite difference method for linear boundary value problem, and then a ensuing tridiagonal system, how to solve that tridiagonal system by Thomas algorithm. Then the nonlinear things, and before that we will have a higher order BVP. In the many book they do not talk about this, how to handle the higher order BVPs, and they will introduce the block tridiagonal structure for that, and iterative methods for particularly for the nonlinear situations. When you have a nonlinear boundary value problems, there are two iterative methods which are most popular, that will be introduced in this course, and course in the partial differential equations, when the independent variables are more than one, that is two at least we will consider here. So, these linear situations like heat conduction equations, diffusion equations or transport equations, those will be introduced by a popular method or efficient method like Craig-Nicholson method, and these implicit situations, and what is the advantage of implicit scheme in terms of stability and the error analysis. All these things will be discussed over there, and then we will talk about the higher dimension situations, that is the fractional time step situation, the ADI scheme, which is will introduce for two variables, that is two space coordinate, and then we will talk about the Poisson equations, how to 5-point formula or more, because the Poisson equation, the difficulty comes is the solution of this linear system is very slow by any iterative method. So, a acceleration for convergence is the popular technique, is the successive over relaxation. That will also be so this all will be the basic stepping stone, or a basic introduction, a solid introduction I should say, so that if you learn these codes and then you can explore to higher or higher order numerical scheme and other complicated situations. Now, as you must have come across by now several situations where the boundary value problem are applicable. Say for example, one of these is the vortex shading. Say for example, this contours plot which shows the heat transfer through a bluff body, and that follows this heat transfer temperature equation, the second equation. And the first one is the Burger's equation, which is the well known model for any transport phenomena, and then Laplace equation or Poisson equations, and then the very commonly come across equation is that Navier-Stokes equation, which is again a boundary value problem, and also there is a initial, we can say the initial boundary value problem. So, it has all the nature, like it can be elliptic or parabolic. So, these are the some of the examples. So, I believe this course will be quite useful for both undergraduate and in the future if you want to go further from. So, this will be a good introductory course for even for the PhD level as well. So, I wish all the best, and for the course I have put most emphasis by working out several examples, and will be giving assignment also. So, I believe that I have taken full care so that this course will be well equipped and self-sufficient. You need not have to bother about any other supplementary things. Okay, thank you.